Dear students, now we are going to discuss logic gates. Logic gate is an electronic device which has two or more than two inputs and only one output. So, as this logic gate, its name suggests, it uses logic inputs, that is inputs in the form of logic states, whether this input is 0 or 1 and output is also in the same form, that is the logic state form. Therefore, it is called as a logic gate. Basically, there are 7 types of logic gates: AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate and XNOR gate. So, these are the 7 logic gates. Out of these 7 logic gates, first 3, that is AND gate, OR gate and NOT gate, these are called as basic gates, whereas NAND gate and NOR gate, these 2 gates, they are called as universal gates, and XOR gate and XNOR gate, these 2 gates, they are called as exclusive gates. So broadly, these total gates, they are divided into 3 categories, that is basic gates, universal gates and exclusive gates. Now we will see one by one. Basic gates: AND gate, OR gate and NOT gate. Now this is your AND gate. This is the symbol of AND gate. Simple symbol it is there. That is, this is a vertical line and a half circle it is there. And to the left of this vertical line or to this half circle, there are 2 lines which are denoted by A and B. This is the input for this logic gate. Whereas Y, that is the single line, this is the output of this AND gate. So, this is the symbol of AND gate. Now, this AND gate has logical equation. That is, this output is depending upon input, as we discussed, but there is a relation between these inputs and this is given by this output Y is equal to A dot B. The meaning is that the output is nothing but the product of its inputs. Whether there are 2 inputs or more than 2 inputs, then it may be 10 inputs, 100 inputs, whatever it is there. There is no any change in the result of the output. So Y is equal to A dot B. Now this idea, that is Y is equal to A dot B, can be understood with the help of a table which is known as truth table. So this is the logical table for understanding AND gate, which is called as the truth table of this AND gate. So as there are only 2 possible conditions, so therefore 2 logic states, so there are total 4 possibilities which we can give as input to this AND gate. That is, either A is 0 or A is 1, like that, either B is 0 or B is 1. So with this combination there are 4 possibilities, that is A is 0, B is 0, then Y is equal to 0. As we are saying, Y is equal to A dot B, so 0 dot 0, the output will be equal to 0. Then A is 0, B is 1, again output is 0. A is 1, B is 0, again output is 0. But when A is equal to 1, B is equal to 1, at that time Y is equal to 1. So A dot B, that is 1 dot 1, is equal to 1. So this is the logical equation which is proved by means of this truth table. So from this truth table, we can characterize this AND gate, and the important characteristic of this AND gate, that is, when all inputs are high, output is high. So from this table you can see that when all the inputs are high, at that time only you are getting a high output. So that is the characteristic of this AND gate. Now the second gate, that is OR gate. Now this OR gate has again the similar type of symbol, only instead of this vertical line there is a half circle which is shown like this, and then there is what we can say that a half circle again it is attached to this. To the left of this symbol there are two horizontal lines which are nothing but the inputs A and B, and on the right side there is only one output, that is called as Y. Now the logical equation of this OR gate is Y is equal to A plus B, or instead of calling A plus B we call it as A or B. This plus symbol is called as OR. So as this logical expression it is there, so if you put all the possible input possibilities to this gate, you will get the output which is shown here. So this is the truth table for OR gate. So when A is 0, B is 0, Y is equal to 0. A is 0, B is 1, Y is equal to 1. A is 1, B is 0, Y is equal to 1. A is 1, B is 1, Y is equal to 1. So this truth table proves the logical equation of this OR gate, that is Y is equal to A plus B. And from this truth table we can have important characteristic of this OR gate, that any one input is high, then output is high. So you can see here the output is high, here the output is high, here the output is high. So any one input is high, output is high. So that is the important characteristic of the OR gate. Now the next gate, that is NOT gate. Now this is the only gate which has only one output, one input and one output. Output is one for all the gate, but this is the only gate, NOT gate, which has only one input. And the symbol is simple triangle with a bubble here. So on left hand side there is A, that is input, on right hand side there is Y, and this is the logical equation for NOT gate. Y is equal to A bar. Whatever you give in the input, it is to be inverted in the output side, and therefore it is called as a NOT gate. So this logical equation can be proved with the help of this truth table also. So here is input, here is output. If A is 0, then output equal to 1. If A is 1, output Y equal to 0. The meaning is that this gate is working as an inverter, and therefore the important characteristic of this NOT gate is it works as an inverter or a complementer. Then the next gate is universal gate, that is NAND gate. First universal gate is NAND gate. Now if you see this word particularly, it is made from AND and N. N stands for this NOT gate. The meaning is that this gate is a combination of AND gate and NOT gate. So AND gate is attached with a NOT gate in the output side, and then whatever the output you are getting, that is nothing but the output of NAND gate. So this bubble, it denotes the NOT gate here, and therefore the logical equation, as you see here, Y is equal to A dot B whole bar. Now as you know, Y is equal to A dot B, that is the output of AND gate, but here if you see this symbol and this symbol, there is a difference of this bubble. This bubble is attached in the output side. For up to this, Y is equal to A dot B, it works as AND gate, but at this moment, it is to be inverted. So output which we are getting, that is Y is equal to A dot B whole bar. So whatever is the output of AND gate, it is totally inverted for the NOT gate, NAND gate for the same inputs. The meaning is that if A, B and Y, these are the two inputs and this is the output, and if you see the truth table, then A is 0, B is 0, Y is equal to 1. A is 0, B is equal to 1, Y is 1. A is 1, B is 0, Y is equal to 1. A is 1, B is 1, Y is equal to 0. The meaning is that at this particular truth table, if you see carefully, you can get the important characteristic of NAND gate. That is, any one input is low. Any one input is low, the output is high. So when you are getting the high output, for any one low input, you are getting the high output. Now if you see, or if you compare this truth table with the AND gate truth table, the truth table or the output side of this truth table is exactly opposite to AND gate truth table. Now this is the NOR gate, which is another universal gate. Again, this gate is made from OR gate and N stands for NOT. So OR gate and NOT gate. As here you see in the symbol also, this is the symbol of OR gate. One bubble it has been attached to the output side. So a NOT gate it has been attached in the output side, and then we are getting the output. So therefore Y is equal to A or B whole bar. So A is equal, Y is equal to A or B. So that is the logical equation of OR gate. Now it is to be totally inverted. So Y is equal to A or B whole bar. And again, if you see the truth table here, A is 0, B is 0, Y is 1. A is 0, B is 1, Y is 0. A is 1, B is 0, Y is 0. A is 1, B is 1, Y is 0. Again, if you see the truth table carefully, you can get the important characteristic of this NOR gate, and that is if all inputs are low, then the output is high. When all inputs are low, at that time you will get the high output. And again, if you compare this truth table with the OR gate truth table, you can see the output side of this is exactly opposite to output side of this OR gate, and therefore it is called as NOR gate. Now the last two, as we are saying, these are the exclusive gates. So first one is your XOR. OR. So it is OR gate, and one more half circle it is there, and therefore it is called as exclusive OR gate, or this is the symbol of XOR gate. And if you see the logical equation of this XOR gate, it is Y is equal to A XOR B. This XOR, a plus sign in a circle, it is called as XOR. And for this XOR gate, if you see the truth table, then you can see A is 0, B is 0, Y is 0. A is 0, B is 1, Y is 1. A is 1, B is 0, Y is 1. A is 1, B is 1, Y is equal to 0. From this truth table, you can get one important characteristic of this OR gate, XOR gate, that for dissimilar inputs, the output is high. So here you can see there are dissimilar inputs. A is 0, B is 1. At that time, Y is 1. A is 1, B is 0. At that time, Y is equal to 1. So for dissimilar inputs, output is high. Then XNOR. So like this XOR, now it is XNOR. The symbol is again similar to this OR gate with a difference of this bubble in the output side only. So this bubble denotes a NOT gate. The meaning is that whatever we are getting in XOR gate, it is to be inverted in for XNOR gate, and therefore its logical equation will be equal to Y is equal to A XOR B whole bar. And if you see the truth table of this XNOR gate, A is 0, B is 0, Y is 1. A is 0, B is 1, Y is 0. A is 0, A is 1, B is 0, Y is 0. A is 1, B is 1, Y is 1. And from this truth table, you can get important characteristic of this XNOR gate, that for similar inputs, output is high. So here you can see for similar inputs, output is high. For similar inputs, output is high. The meaning is that when inputs are equal, the output is high, or sometimes this XNOR gate is also called as equality gate. So for all these logic gates, all these 7 logic gates, you will get one important characteristic, and that is the highlight of this logic gates. With this, I think this is the idea which will make your sense more clear about the study of logic gates. Thank you.